me?
Yes.
Yes, Doktor.
Okay. Okay, we continue with our lecture. But for today, we will learn new topic. It is about trust design. Okay. I have provided you the with the notes. Okay, as in WhatsApp group. WhatsApp group. Okay. Okay, so today gonna be about trust design. Okay, I bet you all have seen what is trust. This trust system, okay, do not only apply to the building, okay, as a to support the roof loading, but the system can also be used as a bridge and also as a long beam. You can use this truss system. I think the most you have frequently encountered for such structure when you pass through, I think, bridge. You can see that the bridge also support the the water pipe, water pipe system, okay, for that particular area. Okay, you can see at the side of the bridges. Okay, normally we'll have, and the pipe normally will be supported by long pin, but using truss system. Okay, so what is truss? Okay, truss is an arrangement of bar or member connected at joint. It is not always the we can have another cross section too. Yeah. For steel, normally we will use angle. Okay. So for truss member, okay, it is arrangement of bar or any other cross section shape. Okay. Ni saya lukis apa ni? Okay, sorry. Ni lukis saya lukis roof terus. Okay. No, saya nak lukis truss. Okay. Arrangement and connected at a point. A point. We call it as node. Okay. Okay. It is essentially a triangulated system, usually straight interconnected structure member. Why? Kenapa triangle? Do you know why has to be in a triangular arrangement? Can you think of the reason? It said it is essentially. Kan? Essentially. Kenapa? Ada orang nak jawab ke? Kenapa? Muhammad Syahrin? Muhammad Syahrizan. Muhammad Syahrizan? Muhammad Syahrizan.
Ya, Doktor.
Kenapa? Kenapa nak triangle system dalam truss? Untuk apa? Kenapa tak buat segi empat je? I mean the arrangement memanglah you boleh nampak ada segi empat ni. Okay, triangular lebih stable kan? Okay, even though you may have rectangular shape of your truss, but believe me, it is actually an arrangement of triangular. An arrangement of triangular. Okay, because it is more stable in terms of have more stability, and also it's related to the strength of the truss. Okay. Okay, next. Okay, truss can be fabricated from various steel section. You may have open section for your truss member, compound section, and closed section. In practice, closed section, normally we use hollow section. Okay, it's not solid section like a bar. Normally, no, we do not use bar. Okay, normally in practice we will use structural hollow section. Okay, so this is the example of open section. This one closed section, and this is the compound section. Okay. Okay, truss, truss can be divided into two categories, planar truss and space truss, kekuda satah dan juga kekuda ruang. Planar truss, okay, truss normally we will design as a pin jointed frame. Okay, the reason is for the to ease our analysis, trust analysis, untuk memudahkan. That's why we assume as a pin joint, but it's normally pin joint. Okay. Okay. Some member may be designed as continuous. Then member in 3D dimension, we call it as a space frame, space truss. So awak ada dua truss, kekuda satah, kekuda ruang. Dan memang kita assume pin joint supaya memudahkan kita punya analisis. Memang untuk memudahkan. Okay. Okay. This is the figure, example for planar truss. Okay. Do not confuse with 3 dimension. Yes, this figure is in 3 dimension, but this is planar truss. As you can see, the truss is in just one plane. Satu satah je. It lie on one plane. This is also we design it as a planar truss. See, we will design this side and the other side as the truss member. Yeah. Okay. Okay, this one. Okay, now I hope that you can see, you can differentiate planar truss with the space truss. Okay. And roof truss should be designed by structural engineer, okay? But it doesn't mean that you have to come out, okay? Come out with the shape, the arrangement of the truss. You will decide the arrangement of the truss member. As for architect, how to put this one? Okay, the truss should reflect what have been said by the architect. Okay, but the truss part will be designed by the structural engineer. Still, you have to fulfill like the height of the roof. Okay, you need to fulfill based on the architect requirement. Sebab bangunan kan final look dia mesti nak kena fulfill apa yang didesign, apa yang diimagine oleh architect. Okay, bila you design tu mesti nak reflect, mesti nak kena dengan dia punya kehendak. Tapi arrangement dalam trust tu you boleh decide. Okay? Sebab arkitek tak belajar berapa banyak member you nak. Arkitek do not know how many members in your trust system. Okay, so it will be the responsibility of the structural engineer. Okay, this is a type of truss. Okay, there's no further detail on this that I would like to explain. Okay, I want to introduce to you a few terms that used in truss system. Okay, the uppermost member is top chord. This one, top chord, or rafter. The bottom part, we call it as a bottom chord. Bottom chord corresponding to the lower horizontal member. Lower horizontal member. Top chord, this one, it can be inclined member or also horizontal member, but at the uppermost of the truss system. And then we have vertical member, but this is also internal member. You can call it as a vertical internal member. Okay, and we have slope internal member or incline member. Okay, but both vertical and incline member also known as a web member, and these are nodes. Nodes. Okay. This is concentrate load. Okay. For simplicity, we assume loads. Okay, loads will be on the node point, but it is not always the case. Sometimes you may have load that located in between nodes. Okay. Okay, this is another figure. Okay, with more terms. Okay, overhang. Okay, again top chord. This is the peak. Okay, rise, run. Okay, to ni angle lah. Okay, load bearing. This is overhang. Okay, like I said, you may have a rectangular shape for your truss system, but still it is an assemble of few triangular shape. Okay, this is the joint, or we call it as a knot. Okay. Okay, top chord, bottom chord, like I said, vertical member and also incline member, and also known as a web member, means the internal member. Okay. Okay, this one just want to show you what is gusset plate. This one showing to you timber truss. Okay, the most basic understanding. The most basic understanding. Any structure, any structure that under loading will react, and of course they will transfer the load to the other structural member. Okay. As in this figure, you can see that this frame or the simple truss system, okay, is subjected to concentrate force. Okay, due to this force, okay, you can see that the member LB will expand. it will move upwards, which resulted the member AB to experiencing tension. Okay, then the C point here will move downwards. Okay, will move downwards, and the AC, CB will experiencing compression. Okay, okay. Tension member as for member AB, tension also known as a tie member. Compression also known as a strut member. Strut member, the term of strut is suitable to use for truss system only. Do not use strut for column. Column is also compression member. What we do not call column as a strut member. In fact, we can use as a post member. Okay, post member apa? Strut is suitable for truss system. Okay, in order to get good structural performance, the designer can ensure that the ratio of span to truss depth in between 10 to 15. Okay, 10 to 15. Actually, you can use simple formula to get initial dimension for the truss, for your truss. Okay, I'll show you in a bit. Okay, let's say, okay, imagine that you have a truss, okay, with span of maybe 20. This is long truss, okay, long truss. Okay, make it 30 meter, long truss. Okay, then for long truss, of course, I don't think you need slope truss. Okay, but instead you can use flat truss, because this is like a beam. Okay, if you need longer beam, okay, you can use truss system to be your beam. Okay, so let's say this is long truss, and then let's say you have this kind of arrangement. Okay, inside. Okay, oh, it's not similar. Okay, it's not macam ni lah. Okay, then okay. Okay, so in order for you to get what is the suitable height here, you can use this simple formula. The depth is equal to L over 15. Just to create the preliminary truss size. Okay, and then if you have loading UDL load, let's say. Remember, this is like a beam. Like a beam, already learned RC design. Okay, then you can have moment here. Okay, based on this moment, you can estimate what is the suitable height for this truss. Okay, because for long truss, of course, deflection is quite crucial. Okay, it's like it may control your design. So you need to pay more concern on the allowable deflection here. Okay. Okay, to get an efficient layout, okay, of the truss member between the chord, the following is advisable. Okay, the inclination, okay, the angle of the diagonal member in relation to the chord should be between 35 and 50. Ideally, okay, load should be applied at node. Okay, that is ideal. Okay, ideally, load should only be applied at note, but it is not always the case. Like I said, you may have loading in between the notes, okay? In between the notes. Okay, one more thing. You have learned how to analysis trust. I think during your, what subject? Subject apa? Buat analysis of trust.
Structure analysis, Doktor?
Analysis.
Analysis. Structure analysis. Okay. Can you name their method to analysis their trust member? Can you, how, in
Joy
order
method.
to internal force? Kaedah apa? Kaedah
Joy,
apa?
joy method.
Geometry you panggil?
Joy method.
Okay. Joy method. Okay, joy method. Yep, joy method. Lagi?
Alternative.
Alternative tu maksudnya you by diagram, right?
Yes.
Okay, what else? Ada lagi satu. Cut section. Okay. Okay, cut section. Yeah. Okay, good. And did you notice that for trust member, it should be carry only axial force? Perasan tak? Sepatutnya should be only carry axial force, daya paksi. But if you have point load in between nodes, okay, in between node like this one, this is a node, then you have point load in between nodes. The trust member, okay, the trust member you analyze, you know that they will carry internal force, okay, in the form of axial force. It may it can be the tension force, it can be the compression force, but it is axial force, daya paksi. Okay, but if you have load in between nodes here, means this member will have some sort of bending, the response due to this load. Okay, bending. Yeah. Okay. So you need to design this member axial. Normally we use N as to represent the axial force plus bending. Then you need to refer to Eurocode, yeah, and look for axial plus bending clause. Okay, clause to design member that subjected to axial plus bending. If you only have axial force, then the member will respond in terms of it will expand, okay, because of the tension force. It will being pulled because of the tension force, or it will extract due to the compression force. It will shorten due to the compression force. Okay, logic, So, like I said, the ideal is to have load on node. That is the ideal because it will ease your analysis. It will ease the analysis process. Okay? Okay, boleh faham Okay. That's in terms of the efficient layout. Okay? Okay, and the other thing, the diagonal member, the orientation of the diagonal member, the incline member, the diagonal member, if you could ensure that the longest member will be in tension, that will be good. Because if the longer member being subjected to compression, okay, the design process will be more complex, and we're afraid that the member will fail because of compression member, okay, will not only the response of the compression, the response of the member to the compression force, it will not only shorten, but it may buckle. Buckle is the failure mode for any compression or any structure that being compressed. Okay, and the capacity of the member will reduce as the length increase. I mean, the longer member will be more prone to buckle easily. Okay, bila awak punya member yang paling panjang, kalaulah di dalam compression, dia akan mudah fail. Sebabnya compression ni, okay, compression member ni kalau lagi panjang, lagi senang dia buckle. Okay, you can prove that situation by push your ruler. You may have a short ruler and long ruler. Which one will buckle first? Okay, that is the terminology. Okay, for the compression, the situation for the compression member. So if you could ensure that the longest member in your truss system will be subjected to compression, that will be good. Okay. Joint in structural steel are invariable. You can use bolt. Actually, you can use bolt or weld. Bear in mind, weld connection is much more expensive, and especially if you have to have on-site weld, dekat site you nak weld, okay, on-site weld, okay. But it will be easy if you can, if the process can be done at the workshop, okay. Okay, moment are usually ignored because normally we assume the joint is pin joint, okay, is pin joint. Okay, but we have one truss type that could not be assumed for pin jointed during analysis, which is, I do not know how to pronounce it. It could be Verendel. Okay. Okay. We assume the joint is pin joint, means that the member are free to rotate. But sometimes because of the assembly, okay, during the assembly process, sometimes maybe you can have eccentricity. Eccentricity will create moment. It could be just a nominal moment or small moment, but okay, it is quite difficult for you to ensure that the joint are really pin joint. If you want to ensure that your joint are pin joint, make sure, okay, all the axes, okay, will meet at one point. See, it will meet at one point. So you will not have eccentricity. Remember, here, oops, okay, here are the internal force, okay, acting in this point. If you have eccentricity will create moment. Moment is force times distance. The distance is eccentricity for this truss member. Okay. Sometimes you need to consider, okay, moment, especially if you design for industrial truss. Okay, you need to consider. If it's just a domestic or small just a domestic trust for domestic building, or okay, it will be small trust, okay, you may ignore this one. Okay, this is Verandale Trust. Verandale Trust, okay. Okay, other design consideration. Okay, trust of course may be supported by column or wall. If okay, for it can the truss roof bay are economically spaced between 4.5 to 6 meter. You may need bracing member. Okay, you may need bracing member. Okay, for stability. Okay. The longer member, okay, in tension, and the shorter member in compression. If you can ensure this, good enough for your design. The arrangement of internal bracing depend on its span. Okay, rafter. Rafter is also known as a top chord. Okay, sometimes your truss member may only have rafter member. Your truss system may only have rafter member. Macam ni je. That's all. That is rafter. Rafter are normally divided into equal panel length, and ideally the purlin should be supported at the knot point so that rafter are subjected to only axial force. Okay, see? If you can ensure that purlin, okay, what is purlin later on? Purlin located at knot point. Okay, remember I said that load, okay, the ideal is to have load on knot. Actually, these loads are coming from purlin member. Purlin's member. Okay, purlin will support the roofing system. Okay, dia punya atap roofing. Okay, all the load from roofing will support by purlin, and then the purlin will transfer to another truss member, the top chord, and also the internal member. Okay, so if you can have purlin located at knot, means that the load will transfer from the purlin to knot. Then your truss member will subjected to only axial force. Ini dikenakan axial force saja. Kalau awak dapat pastikan purlin duduk atas knot. Macam saya kata tadi, kalau purlin duduk in between knot, ada bending. So your truss, okay, you punya truss member akan ada axial plus bending. Okay, so ideal is to have purlin on knots so that the load will be on knot point. Then the truss member will only subjected to axial force. Otherwise, the truss member may have to support bending. Yeah, bending. Okay, however, in some cases, purlin have to be supported between knots. See, knots point in the rafter. Then you have to design for bending and shear in addition to axial force. You have bending, you have shear, and axial force. Okay. This one is about internal force. When you analysis the truss member, okay, you have like a 3 method. Okay, I hope that you notice that all the internal member in the form of tension or compression. Yeah, kan ada dua je kan? Okay. Okay, this is truss, this is section, method of section, this one, method of joint. Okay, so This is just a 3D. Okay, I just want to highlight that this, okay, you have roof covering, right? Roofing system, your roofing system, you have roofing system or roof covering. This one can be asbestos. Kita dah tak guna, we no more longer use asbestos, okay? Cement asbestos, okay? Normally we use concrete tiles or steel decking, okay? Steel decking will arrange, will look like this, means that the loads are on slope. On slope. The load are on slope. Okay. This one, as you can see here, I just want to introduce to you, okay, the term of load on slope, load on plan. Okay, this one is on plan. Okay, on plan. This one on slope. So roof covering, okay, will transfer the load in the form of in the type of on slope load. Okay. Okay. I hope that you can imagine. Okay, this is truss number 1, truss number 2, truss number 3. Okay, and then in order to to accommodate, okay, in order to accommodate the roofing system or the roof covering here, of course you need purlin. Purlin is a member that run from truss to another truss system. See, it is like a beam also. This is like a beam also. It is a bending member. Purlin is a bending member. Okay. It will not support. It will no. The main load. Okay. The main load will be in bending load, not axial. But truss is axial load. It is significant. Okay, for truss. But for purlin, it is a bending member. So then you have roof covering. Okay, the distance of the purlin, it will depends on your requirement. Depends. To me, it will depends on the type of roof covering that you use. If you have cement tiles, okay, it's like a S shape, right? S shape, then S shape. Of course, you need something to support your the S curve here. So you may need to arrange your purlin, okay, with certain distance to accommodate the these tiles. Okay, okay. Purlin, okay, like I said, okay, will carry roof sheet or roof covering. Kita panggil atap lah, okay. And transfer the load to the rafter. Yep, this is rafter. And then you will have a purlin member here, okay. And then this is where you accommodate the roofing system. You will tie the roofing system, okay, to the purlin, okay, to the purlin, okay. Then means that the purlin will support the load from the roof, and then purlin will transfer to the truss, another truss member, okay. Okay, the analysis of truss is carried out to determine axial force, or I always say as internal forces, yeah, in the member. In certain case, the bending due to the applied load. If you have purlin located in between nodes, means that you apply point load to the member. Member in between node. Okay, so for this member, it was subjected to bending plus axial force and also plus shear lah, shear. Okay, trusses support purlin. Agree? Truss support purlin. Okay, purlin also known as a secondary member. Okay, roof load will transfer to the truss at joint by a series of purlin. Ni series of purlin. You have more than one purlin, of course. Okay, purlin also provide lateral support to the top chord. In what way? Okay, because you're gonna tie this one. Okay, so your roof will not deflect in this direction because you already tied, you already tied the purlin member to the trusses. So your trusses gonna stick there at specific distance. Yeah, so that's why we said that also provide lateral support to the top chord. Okay, load. What about load? Okay, basic load. You have permanent action, you have variable action. Okay, permanent action also, permanent action coming from cladding, insulation, ceiling, also separate of the truss and purlin. Where for variable action, okay, based on Eurocode, you can choose between these two based on Eurocode. MS, I do not remember. I think it is 0.5. Last time it's 0.25, but I think they already increased that. Okay, 0.75 according to Eurocode. This load, okay, kilonewton per meter squared. These load are for roof truss where only can be accessed for maintenance and repair. You have to opt for this value 1.5 kilonewton meter squared, which is much more bigger. Okay, if the truss have additional access, more access than the above. Okay. Okay, another load is a wind action. Okay, last time we used BS 6399 part 2 and the older version CP3, okay? But now you can refer to Eurocode part 1, 4. Okay, so action can in the form of suction force or uplift force, or it can add it can add down in downward direction, downward ke bawah. But wind action add normal to the roof surface. Okay, normal panggil apa? Perpendicular. Yeah, perpendicular. There are 4 combination of load. Okay, this is a load combination. You can consider only dead load plus imposed load, dead load, imposed load plus wind load, dead load plus wind load. And then you check which one will give you more severe load case. Based on that, you need to consider the load for your further analysis. Although normally combination 2, dead load and imposed load are normally assumed as the design criterion. Okay, however, in practice, these are all the combination that you need to consider, especially where the wind load is high. Okay. Okay. Okay, this is purlin again. This is purlin. This is purlin. Okay, this is rafter. This is purlin. Okay. Okay, and this purlin. Okay, now you can see it use a lip channel, and then okay. We have set rod here. Why we need set rod? Okay, if your purlin is small and then it need to run from one truss to another truss with a longer span, okay, let's say this is longer span. Remember, this is a bending member, okay? It is a bending member for purlin, bending member. So to decrease the deflection of this member, we need another support, okay? That another support in the form of sag rod, okay? Just to reduce the bending, the deflection, because this is a bending member. Purlin, purlin. Jangan confuse dengan truss member. And purlin, secondary member. Main truss member, you have top chord, bottom chord, internal member. Okay, this one also purlin. Okay, before we go to the design part, okay, please assess your author. I have, okay, as usual, I want to have more frequent pop quiz with you for me to ensure that you are here and also you pay an attention, okay? Okay, let's see. Okay, oh, almost 1 hour. Almost 1 hour. Okay. Okay, are you okay? We have like a 3 minutes only. Okay, so okay, just a simple question that you can, I think you can answer. Okay.
Doktor,
Ya,
kenapa saya tak keluar?
tak boleh keluar.
Tak,
Tak
tak,
ada.
maksud saya tak ada dekat author.
Awak,
Quiz tu.
orang lain ada tak?
Ke assessment.
Assessment, ke assessment. Cepat, lagi 2
Okay,
minit.
thank you.
Okay. Okay, dah? Okay. Mana yang lain? Abdi Majid? Abdi Majid? Abdi Majid?
I'm here, doctor.
Abdi Razak? Why you not answer?
Doctor, on the way.
On the way. I don't think you can access anymore. I have put limit time. Masih boleh buat ke?
Doktor
I don't think
put pukul 3. Patutnya doktor set 14. Tapi doktor set 15 tadi.
Oh, okay. Okay, time's up. Time's up. Mana otak? Saya letak berapa? Okay, kejap ya. Ai, lamanya. No. Time's up. Okay, I'm gonna hide this one. Takut pula hilang. Okay. Time's up. I already export the response. Okay. No more response. Okay. I will not count that one. Okay. So we continue. We continue with the design part. Okay. Okay. Like I said, Berlin is like a beam. I know that you still not learn how to design beam, but you already learn during the structural design. Betul tak? Kan? Ada belajar beam design during structure design? Subject structure design? Ada tak?
Ada.
Ada buat Okay. So beam bending member. Okay. Purlin. Okay, you can design like you design as a beam, or we have another alternative method, which is empirical method. Just that empirical method, you can the procedure is referring to the old code, which is BS 5950. In order to use this procedure, which are listed in this clause, okay, in these two clause, you need to meet specific requirement or specific condition. In general, you can use empirical method if the thrust, okay, if the angle or the slope of thrust is less than 30. That is the first one. Then the loading on purlin is uniformly distributed, not point load. Okay, then after that you can use table 27, not 29, I think. Okay, table 27 in BS 5950, where in this table you can have Z value, D value, and B value. Okay. Okay, I extract some of the information from BS 5950. You can always Google it, and if you want to read, okay, Google it, download it, okay. Okay, from this clause, okay, this is for purlin and side rate, but my focus will be on purlin. Okay, then you can read, okay, this is the general rule. Okay, the minimum grade for steel, okay, in order for you, the minimum grade for steel, okay, that you need to fulfill before you use this table 29, not 27, okay, table 29. Okay, the steel grade should be grade 43, but 43 is the old term. 43 is equivalent to S275. Okay, S275. And then we use unfactored load to do the analysis, okay, to calculate the, to be considered in this, for this parameter, WP. WP is total unfactored load on one span of the purlin in kilonewton due to either dead load plus imposed load or wind load plus dead load. This one means for combination load. It depends, okay? Like I said from the previous slide, okay? See? You need to carry out all this combination and look for the most severe load, severe load case. And then let's say the severe load case is from the combination of these three force, these three loads, and then you need to use this load for further analysis. Okay? Means that you have to consider this one. But unfactored load, okay, not the design load. The design load will be 1.35 GK, 1.5 QK. Design load, consider partial factor. Unfactored load means that 1.0 GK, 1.0 QK, 1.0 WK. Okay, that is unfactored load for you to use to analyze the purlin, the purlin member. Okay. So use unfactored load. Span to member should not exceed 6.5 center to center of the main support. What does it mean, main support? Do we have support on purlin? Yes, we have. The support is coming from the rafter. Kan? Did you notice that? Okay, notice tak? Purlin is being supported by rafter. This one, the top chord. So center to center, it said do not exceed 6.5 meter. Okay, and then at least 2 fastener. Okay, where member are generally continuous over 2 or 3 mobile with staggered joint in adjacent line. Okay, dah tak nampak dah. Okay, it should be connected. Okay. Okay, sorry. Of the member, at least one end of any single bay member should be connected by not less than 2 fastener. Okay. Okay, this one is specific rules for this empirical design. Slope, do not exceed 30. Okay. And then loading should be substantial uniformly distributed, not greater than 10% of the total roof load on member should be due to other type of load. Imposed load should be determined as recommended in 2.2 but should not be taken less as 0.75. Then you can use this table. Okay, actually this table give you the limit value, the minimum value of Z, D and B. What is Z, D and B? Okay, table 29. Okay, again I repeat, table 29 give the limitation value, which is the minimum value that designer must fulfill. Okay, from this table you can get minimum value of Z. What is Z? Z is represent modulus of elastic, but according to Eurocode, modulus plastic is WPL. So Z is the old version of modulus of elastic. Dulu-dulu kita guna Z sebagai modulus elastik, tapi untuk Eurocode modulus elastik adalah WPL. Okay, let's refer to Eurocode. BS. Do you have Eurocode with you now? Do you have Eurocode with you now? Eurocode or Blue Book? Ada tak?
No, Doctor.
Kenapa tak ada? Why? Why don't you have? I said Blue Book can be download free from the internet. Do I need to supply to you? You are not kindergarten school. In kindergarten school. Saya dah bagi tahu you kena ada. Habis tu nak buat apa ni design? Saya cakap je. You tak ada refer. You boleh sambil baring pun boleh dengar saya cakap. Kalau you ada benda tu, you akan lebih ni. Kenapa tak download? Any reason? Any reason? Kenapa tak download? Kenapa? Kenapa tak download? Ni saya kena cakap free je. Download lah. Download sekarang? Saya bagi 2 minit. Kejap nanti saya nak tulis-tulis ni, kalau you lepas saya tak nak repeat dah. Sebab kita akan guna ni sepanjang semester proses ni. Saya tak nak tunjuk dah mana W, mana apa ni, saya tak nak. Tolong download sekarang. Cari dekat Google tu. Dia dalam SCI punya website je pun. Saya bagi you 2 minit. Download sekarang. Mana ni? Seminggu gap. Boleh pula tak ada. Inilah kelemahan online. Saya tak tahu apa yang awak tahu. Kalau tak saya boleh ronda-ronda, tengok you blur-blur sikit, saya boleh tanya apa yang tak faham. Seorang boleh download, share dalam grup? Seorang download ke? Share dalam grup. Takkanlah saya nak bagi semua. Thank you. Siapa ni? Y ni siapa? Okay. Then buka. Okay. So last time, during my time, we use capital Z, okay, to represent elastic modulus. Saya cakap tadi plastik No, elastic modulus. For elastic modulus, okay, you can use symbol. You can use, elastic modulus according to Eurocode, all the formulation, all the formula will use this. Alamak. W. EL represent elastic. This one at axis Y. This one at Z. Plastic modulus represented by W, PL, plastic. See, W is modulus. PL means plastic. I could put Y to represent the modulus, the plastic modulus for Y axis, or I can say I can put as Z to represent plastic modulus at Z axis. Okay. So second moment of area represented by I. This Y can be IYY, IZZ. Any radius of gyration is R. R. RY, RZZ. Okay. Or sometimes in the formula, Radius of gyration also known as lupa R. Sorry, I forget. Okay, nanti kalau saya ingat saya beritahu. Okay, so okay, Eurocode use W, while for PS they use Z. Okay, PS they use Z. Okay, but actually it is represent the same thing, which is modulus of elasticity. Okay. Okay. So, hey, that's all. Okay, that's all. Like I said, from table 29, you can have minimum value of modulus elastic that you need to fulfill. The designer need to fulfill. D represent the depth of the section that you want to propose. Okay, let's say from the calculation you get 100 for D, means that you the section that you need to propose should have minimum 100 mm as the depth, as the D dimension. B is for the width or for the breadth. Okay, the drawback of this approach, it offer you limited section to be used, angle, channel, or rectangular hollow section. That's all that you can use based if you design according to this empirical method. That is the drawback. If you design it as a beam and the procedure according to the Eurocode, you can have any sort of section shape. Okay. Okay. Now we go for okay. This one, same thing, is showing you the table 29. Okay. Let's do one example. Okay. Let's do one example. Okay. Okay, we want to design Berlin according to empirical method. What do you understand about the words, the empirical? Apa yang awak faham tentang empirical? Kaedah empirical, what's that mean? Kaedah empirical.
Simplest method.
What is empirical method? Empirical method, of course, involve empirical formula. Empirical method will use elastic stage, okay? Empirical method we use elastic stage, okay? Okay. First example, you'll be given impulse load, okay, QK 0.75 kilonewton per meter squared. Meter squared here represent the area, okay? Dead load 3 kilonewton per meter squared. Spacing between trusses 5 meter, purlin 2 meter. Okay, then you need to determine the load, okay, on the node point. Okay, let's say this is the arrangement of the truss in this example. For this example, okay, I highlight node A, B, C, D, just one side of the truss member because it is symmetry. Okay, this is elevation view, this is the plan view, but this is the peak or apex peak or apex. So this is apex. The diagram should be in this direction actually. Should be in this direction. Or here. Okay. But it doesn't fit my slide. See, A here, B here. Okay, but it doesn't fit my slide. I do not have more space. Okay. Try lah. Tapi dia lari. Nampak? Tak cantik langsung. Okay. So I just rotate, okay, in this direction. But please, this is apex, which is this one. A, which is this one. B, this point. C, this point. D, this point. Okay. It said that spacing between truss is 5 meter. Means that at the back of this truss, let's say this is the first truss, the second truss, the interval, the distance is 5 meters. See, this is truss 1, truss 2, 3, and 4, and so on. Okay. Why not? Okay. So at the back, we will have another truss. Okay. But the distance will be 5 meters according to the information. The spacing between trusses 5 meters, and then purlin spacing 2 meter. 2 meter. Let's say we put our spacing 2 meter here, which is on knot. Let's say on knot. Okay. Okay. Let's say on knot point. Yeah. Okay. This one is 2 meter. Okay. How can we analyze? Okay. Now we have GK. We have QK. The GK is 0.75 kilonewton per meter squared. QK is 5 kilonewton. QK 3, right? Kilonewton per meter squared. Okay. Okay. Just a simple analysis. Okay. Of course, your purlin will run from first truss to the other truss member. This one. This is the purlin. Okay, imagine that this purlin, on top of this purlin will be roof covering. Okay, you will put your roof covering here. And then imagine again that this roof covering, okay, will be support, of course, by these two member, these two purlin member. Okay, boleh nampak tak green color here? I hope that you can see. Okay, you can clearly see. Tukar sikit lah. Mana? Okay. Insert. Mana color? No color. Oh, sorry. Salah. Oh, this one. Oh, sorry. Salah. Okay. So, means that this roof covering are supported by these two purlins. So, assume that half of the area will be transferred to the first support, while another half to another support. Okay, just imagine. That's why we can have like this rectangular area. That this rectangular area actually half of this distance, half, ST divided by 2, ST divided by 2. This is truss, right? Truss 1, truss 2, truss 3, 4, 5. We have another truss, truss 1, 2, 3, 4, and then 5. Okay, and then you have purlin. Purlin here. This is distance of purlin, ST. This one, ST. Sorry, SP. This is ST. Truss, this is SP. Purlin, spacing of purlin. So half, also half. This is the knot point. So half go to this support. Yeah. Okay, go to this point. And then another half go to this point. Okay? Boleh faham tak? Boleh faham tak? Tolong respon. Tak faham, cakap tak faham.
Boleh doktor.
Okey. Ni ya. Okey. Okay. This will be, okay, this is truss Truss number 1, 2, 3. Boleh imagine? Boleh imagine tak? You imagine this is the
Boleh
truss.
doktor.
Okay, boleh ya. Truss and then you have purlin. Purlin here. Okay, and then this truss. Okay, and then you have roof covering here, roof. Okay, your roof will be being supported by these two purlin, and then you have another roof covering attached, okay, to the purlin. Okay, we connect to the purlin. Okay, then okay, yeah, this is not, okay. Banyak knot. Okay, just take one critical knot. Critical knot is located at intermediate. Okay, intermediate knot. Do not choose the knot that located at the end of your truss or your roof member at the end. Tak nak. Because it will only support half of the area. But intermediate knot will support full area. Okay, so this knot will support loading from okay, half of this area, half of this span will be transferred to this knot. Another half will be transferred to this knot. Another half transferred to this knot. Means that this one knot point here will support this area, the loading area. Okay, when I said half means that ini apa? ST or SP? ST, right? So ST in our example 5 meter. So here 2.5, then another half 2.5. Lepas tu this one SP as purlin. Okay, only half of it. Okay, SP purlin 2 meter. So half here means 1 meter. Another half 1 meter. Okay, so the total area that this point support, okay, area is 2.5 plus 2.5 will be 5 again. 1 and 1 will be 2 again. So area that this point will cater is 5 times 2 meter square. Okay, like in this example. Okay, so so the total load here, total load on purlin, okay, will be design load multiplied by area, because your design load in kilonewton per meter squared, area is in meter squared, then you can get load in kilonewton unit. What is design load? I said design load is something that you multiply by partial factor. But in this case, for purlin design, according to empirical method, it said unfactored load, means that 1.0 GK plus 1.0 QK. Okay, let's say I'm using GK dead load, permanent load and variable load combination. But you have another combination load, right? You have like a 4. Okay, plus also wind load. Okay. Okay, let's say I'm just using typical case 1.0 GK and 1.0 QK. GK plus QK, dead load plus input load, or permanent load plus variable load, but unfactor. So I put it as a 1.0. So this is the design load. So the design load here, okay, design load will be GK.
Doktor,
Yeah.
boleh tahu tak kenapa guna 1.0 GK dengan 1.0 QK? Tak faham lah Doktor.
Sebab, remember this one? Remember this one? It said unfactor load. Saya nak gunakan empirical method. Bila saya nak guna empirical method, saya akan guna kod yang lama, BS5950. Dalam BS5950, dia dah cakap kat sini. General rules to use for empirical design according to this clause. First, minimum steel is 275. Second, consider unfactor load for empirical design, means that the partial factor here is 1.0. Boleh faham?
Okay, faham Doktor. Thank you Doktor.
Okay. 1.0 GK berapa tadi? GK berapa please?
3 Doktor.
3.
3 plus 1.0 QK 0.75. Remember unit. Unit. So this one is like 3 plus 0.75, which is 3.75. Okay, kilonewton per meter squared. So here 3.75 kilonewton per meter squared multiplied by 10 meter squared. Meter, habis 3.75 times 10, so 37.5 kilonewton. This is the load acting on your node point. 37.5. Okay? Senang je. 37.5. Okay? Kenapa 51? Okay. Okay, maybe ini load lama. Last time kita guna lain 337.5 kilonewton. Ini ini 37. Okay, all this the load are all 37.5 except at the not at the end, because the end node, the end node here and here only support half. Okay, this one should be divided by 2. Okay, only support half. Why half? Kenapa half? See, this is another node, right? Okay, only half of the original area, which is 5 meter squared. Kan, dah tak ada dah kan? Tak ada kan? So, should be 37.5 divided by 2. Okay, 18 point. Okay, so far macam mana? Boleh faham? Senang je kan?
Boleh.
Okay Doktor.
Okay, next. Ini ada salah sikit. Oh, you tak ada benda ni. I think next saya terangkan the next class. Okay. Ni pun. Next class lah saya terangkan. Okay, kita buat lagi satu assessment. Okay. Satu assessment. Get ready with your author. Okay. Kelima ya. Okay. So, ada 4 minit. You have like a 4 minutes.
Sorry, Doctor.
Yep.
Didn't make the save. It said times out. I forgot that save. You can't just save.
You draw and give me the answer using WhatsApp now. Now, give it to me now. Okay?
You mean
Because
take a picture?
I could not do amendment in Otter because it will delete all your friends' answer. I could not do some amendment.
Okay.
Okay? Now, okay?
Okay.
Okay, I already received that.
Thank you so much, Doctor.
Okay. Okay. We proceed to the okay. Sorry. Before that, I want to verify something before I give you another example. Please bear with me. Okay. Okay. I want to give you another example. Let's say if you have GK. It's not in our module. GK is 0.45 kilonewton per meter squared. Okay, and the dead load in the form of on slope. On slope means that the coming from roofing system. Okay, roof covering. Then the GK, QK, 0.75. 0.75 is on plan. Okay, on plan. Okay, then you have a truss which span 12 meter, and the rise until rise is 2 meter. Instead, you have 12 meter here and 2 meter here. Okay. Okay. So, okay, another example. The T 5 meter. The ST is 5 meter. Okay. Can you determine what is the value of this load on node point? Okay. Okay. First thing that you need to calculate, you know that loading is 1.0 GK plus 1.0 QK. This is typical, okay? Like I said again, I stress again, you need to consider load combination. So this is 0.45 plus 0.75. Berapa? Oh, no. See, I also forget. This one is on slope. Means that the loading will be on slope, while QK in the form of on plane. You cannot directly add these two values because it is not in the same, I would say in the same, even not in the same apalah. It's still in the same unit but referring to another area. Okay? It's referring to another area. So you need to change the QK. You need to change the QK in the form of slope. Okay? So it should be 0.75 times this 6 meter divided by this one, hypotenuse. Okay? Hypotenuse here. Okay? What is the value of hypotenuse? 6 power of 2 plus 2 power of 2 and then square root. Or we call it as a length of rafter. Okay? This one berapa?
6.32.
6.32. 6.33.
6.32.
33.
6.32, okay. 6.32. So 0.75 times 6 times the 6.32. 0.712 kilonewton per meter square. So this is already on slope. Now it's already on slope. Then now you can add these two value. Campurkan 0.712. Berapa? Okay. Berapa? Ini kilonewton per meter square. Okay. Help me.
Sekejap doktor tengah kira.
Two, 6, 11.
1.162.
Kan? Okay, so this is in kilonewton per meter square. Okay, in order to get the value of this point load subjected on this node point, like I said, please consider the intermediate node. Okay, let's say this is truss number 3. Okay, truss number 2, truss number 1. Okay, this is truss, and then purlin will run from truss to truss. Okay, and then choose the most severe condition. Severe condition is the intermediate node. Okay, so for intermediate node, it will support area, okay, area, wow, this big lah, this big half and another half. So truss to truss 5 meter. Okay, purlin to purlin, okay, I do not know. Purlin to purlin, we have 12 meter. This is just estimation, okay? 12 meter, let's say 12 meter, we have 1, 2, 3. Okay, so 12 meter divided by 3. Logic ke? It's not logic actually. We do not have, 12 meter is for the whole span. So half span we have 6 meter. 6 meter we have 1, 2, 3 intervals. So 6 divided by 3. 2 meter. Oh, sorry. No, it's not 2 meter. It's not 6 meter. This is hypotenuse. Length of rafter, which is 6.32. Let's say we have 4 knot point here. So 6.32 divided by 3. The interval is 3, 1, 2, 3. So we can assume that the purling distance is 2.107. So 2.107 half of 2.107, and then add another half. Of course, this one will be again 2.107. This one half 2.5 and another half 2.5. Okay, the total will be again 5 meter. Okay, so P is equal to 1.162 kilonewton multiplied by area. This one is kilonewton meter. I need P because I need point load. Okay, so area is berapa? 5 times 2.107. So P will be 12.2 kilonewton. Boleh? Okay? Boleh? Boleh faham?
Doktor,
Ya.
macam mana dapat 2.107 tadi?
Oh, tadi kan ni kan segitiga hypotenuse. Kuda, saya consider half kan? 6 meter kan? Ni? 6.32. Alah, apa? Ini apa? Ya,
Oh,
yang
trigonometry.
trigonometry.
Okay, thank you doktor.
2 kuasa 2 tambah 6 kuasa 2. Ni, lepas tu saya nak berapa point? Saya ada ni je. Let's say this is my truss arrangement. Okay, so we know that this is node. So the distance 1, 2, 3, ada 3 interval lah. 3. So you divide by 3 because you want to know what is the distance of this purlin. Jarak between this purlin. Okay. Macam mana? Boleh faham?
Boleh doktor.
Yep. Ada nak tanya?
Saya tak faham yang kenapa dia dalam yang nak dapat 0.712 tu.
0.712 ni.
Yang dia dalam 6 yang bahagi tu.
Okay. Saya nak minta you lah buat sebab ini matematik. Okay. Awak kena buat macam ni. On slope. Awak nak dapatkan on awak daripada on plane to on slope. Boleh tak? Ini theta. Jadi keluarkan segitiga ni. Ini mesti 90 darjah punya. Mana theta? Sini ke sini? Again trigonometry. Itu je. Okay?
Okay.
Okay. Lagi? Ada pertanyaan? Tak ada? Okay. Kalau macam tu. Yaka, faham tak?
Boleh doktor.
Boleh
Boleh.
Shusmita?
Yes, doktor.
Okay. Dari minggu lepas saya panggil you, Shusmita.
Oh, sebab line
Okay, faham tak?
Faham.
Okay. Said Muhammad Osman.
Yes, doctor.
Are you here in Parit Raja? Or
Yes.
you? Oh, okay. I thought you're going back to your hometown for Ramadan and Shawwal.
Yeah, if I go to my hometown is very difficult because we have a big gap for 5 hours. Maybe right now in the morning.
Oh, 5 hours in the morning.
Yeah.
The time. I see. Yeah. Don't think you want to learn early in the morning. Okay. Siapa lagi? I hope that you are really can learn something today. Just to sum up what we have learned today, it is about trust, and we specifically did one of the trust member, which is Perlin. Okay, we already did the design of the Perlin. No, we didn't. We do not yet for design Perlin. We just in the stage at the stage of analysis of the trust load. Okay, then later on we go to Perlin design. Okay, later on, I think maybe tomorrow. Okay, as for now, I would like to say goodbye. Thank you so much for your attention. I'll see you again tomorrow. Okay, please be there.
So much.
Thank you.
Thank you.
Okay, bye.
Thank you, doktor.
Thank you,
Selamat
doktor.
raya.
Thank you, doktor.
Thank you, doktor.
Thanks. Okay.
Terima kasih, doktor.
Doktor.